Hello and welcome to another episode of Mr. Franklin Explains Some Math. Today we are looking at our properties of exponents example number 2. This one is about the quotient rule for exponential expressions. In the examples we did before, like x to the 5th times x to the 4th equals x to the 20th, the exponents got bigger when we simplified. You might also have noticed that when we multiply two exponentials with the same base, we add the exponents. It's important to know that this is when the bases are the same. The opposite of that, of course, is that dividing makes the exponents smaller by subtracting. See, dividing is the opposite of multiply, and subtracting is the opposite of adding. This is only when the bases are the same, though. Only when the bases are the same. So here's how one works. This example is x raised to the 7th power over x to the 4th. Please keep in mind that when we say over, or it's in the form of a fraction, what we're really doing is dividing. Just like if two exponentials are next to each other, it means multiplying. Here, when there's one on top of the other, it's dividing. And when in doubt, write it out. So just to figure out what x raised to the 7th power means, we've got x times x times x times x times x times x times x, or x times itself 7 times. And on the bottom of the fraction is x to the 4th, which is x times x times x times x, 4 times. Let me write that out a little bit differently here so I can work with it a little bit. This is the line for my fraction. And on top of the line for my fraction, the spacing's a little off. Let me see if I can fix that. On the top of the fraction, I've got x times itself 7 times. So that's x, 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 x. There's 7 of them there. And on the bottom of the fraction, I've got 4 x's. X times itself 4 times. X, 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 x. Hopefully you can read my big fraction. What we're doing here is we're going to divide. Hopefully you know that anything divided by itself is equal to 1. So if I have an x on the top of a fraction and an x on the bottom of a fraction, I can do x divided by x. In other words, I'm going to just strike those out. I'm going to make that a little bit bigger so it's easier to see. I hope it makes it easier to see. So, can you see how we divided or canceled an x on the top and an x on the bottom? But there's more x's. I've got an x on the bottom here, and if I divide the top and the bottom by x, divide x by itself, those are gone. And I'm going to keep doing this process of canceling or dividing one on the top by one on the bottom, because what those really equal is x divided by x is 1. So 4 x's on the top divided by 4 x's on the bottom, that also has to equal 1. And so what that gives us is it's no longer a fraction because we got rid of all the ones on the bottom, all the x's on the bottom. And so the simplified version of x to the 7th divided by x to the 4th is now going to be, oh look, there's 1, 2, 3, 4 of them left. Nope, I counted that wrong, sorry. There's 1, 2, 3 of them left. So that's going to be x raised to the 3rd power is our answer. And again, I want to reiterate that this works because x divided by x, or when we see it, when we write it, sometimes it's x over x, that's equal to 1. We call this canceling. So what we did here is we canceled the same number of x's from both the top and the bottom, and the answer is what we were left with after we did that. Here's another example. I'm just going to explain this as the shortcut so that you don't have to write it out every time. But if you can't remember the shortcut, when in doubt, write it out. So here I've got another example. When we multiplied exponential expressions, we added the exponents. So it makes sense when we do the opposite of multiply, divide, we're going to do the opposite of add. We're just going to subtract. So this is going to be a raised to the, well, I've got 7 minus 2. Just like in the example above, I had 7 minus 4 equals 3. I can recognize that pattern, see the shortcut, and I've got a raised to the 7 minus 2 is 5. The answer is a raised to the 5th power, or a to the 5. In both of those examples above, the exponent on top of the fraction in the numerator is bigger than the exponent in the bottom of the fraction, the denominator. That can be reversed. You can have the bigger exponent in the bottom of the fraction, and as long as the bases are the same, see this is p on the top and p on the bottom, we've got p to the 3rd, that's 3 p's, and p to the 6th, that's 6 p's. Just like we had before, we're going to, there's my line. Here I've got p times p times p on the top. And on the bottom, I've got 6 of them. P times p times p times p times p. I don't really want capitals. P times p times p times p times p times p. I'm going to make that font bigger. And we're going to do the same thing. When we cancel 1 on the bottom, we've got to cancel 1 on the top. Cancel 1 on the bottom, cancel 1 on the top. Cancel 1 on the bottom, cancel 1 on the top. And now I've got a new fraction where I've got 3 p's on the bottom and no p's on the top. Just need my controls back here. And let me insert a fraction here. And what I've got is now a fraction with p raised to the 3rd power on the bottom. You might see a problem here. What do you put on the top? There we go. In this instance, we canceled all those p's on the top, but remember, they don't just go away. What it is p divided by p 3 times, and p divided by p is 1, and so what we've got on top really is these p's don't disappear, they cancel and they become 1s, so it's 1 times 1 times 1, which of course is 1. And the answer here is when we take 3 on the top and 6 on the bottom and do as much canceling as we can, we're left with just 3 on the bottom, and that empty space on the top is really a 1. So it's 1 over p to the 3rd. There's something weird going on here, though, because we had a shortcut, right, where we just subtracted the exponents. So that would be 3 on the top, 6 on the bottom, 3 minus 6, but that gives us a negative number. And that's a little bit curious. Can you have a negative exponent? Yes, you can. And the next lesson is going to start covering negative exponents and how you handle those. That's enough for today. You should now have some problems to try practicing where you've got a worksheet where you try to find the quotients and simplify some exponentials that are in the forms of fractions. Thank you and have a great day.